Yeah. So hello my dear students, I welcome you to NEET World. So we will be discussing concentration terms here. So in the last session we have discussed few concentration terms. So what are those? Weight by weight fraction, percentage, weight by volume, next volume by volume, next molarity, molality and the relation, mole fraction, and how can we relate molality to the mole fraction and molality to the molarity. All these things were done, okay, and few questions are also solved related to these topics. Right now see here we have few questions like this. So how can you calculate this? A mole fraction of glucose in the solution is made up of 2 moles of glucose, mole fraction of glucose, okay, which is made up of 2 moles of glucose and 4 moles of water. So how can you do this? Mole fraction of glucose I am asking. Very simple question now, very basic question. So mole fraction of any substance or a mole fraction of a component will be equals to number of moles of that component, means number of moles of glucose by total number of moles in the solution. What is that? Solution is made up of glucose and water. So N glucose plus N water. So it will be N glucose, how many moles it is given? 2. So 2 by 2 plus 4, that will be 2 by 6. So 1 by 3. So this question is also we solved in the last class, okay. Now if I ask for mole fraction of water, what is your answer? 4 by 4, that is 4 by 6 again. Like that also you can do, or you can do like this. See, this solution is made up of glucose and water, no? So mole fraction of glucose plus mole fraction of water will be equals to 1. The solution is made up of these 2 components only, right? So the sum of the mole fraction of the components will be equals to 1, okay. So now I want mole fraction of water, that is nothing but 1 minus mole fraction of glucose. So that is 1 minus 1 by 3, that is like do the LCM. So 3 minus 1, 2 by 3, 2 by 3 will be the mole fraction of water in this solution, okay. Like this you can able to do. Very simple questions these are, okay. Let us move for few other questions here in the discussion. Yeah, so now tell me, how can you relate this? Mole fraction of acetone in ethyl alcohol is 0.3. Then molality of acetone in the solution I am asking. It means I am asking molality by giving mole fraction, okay. So what is the relation between molality and mole fraction first? Okay, look at here. Molality formula what we have? So molality equals to number of moles of solute by weight of solvent in kg. This is the formula we have, okay. So now it is in kg. Now I am writing it in terms of grams. So it means number of moles of solute by weight of solvent in grams, okay. So when I am doing like that, just take here 1000. So this will be in grams, so that I am multiplying with 1000 like this. Now what I am doing is, I just want to relate this molality to the mole fraction, okay. Look at here, very easy. See, in the numerator we have number of moles, in the denominator also we required number of moles of solute in the numerator. So here we require number of moles of solvent. For that purpose what I am making is, I am dividing and multiplying with molecular weight of or molar mass of A, okay. So that, see, there is no issue while dividing and multiplication. If I cancel them, it will be 1 only. So we can do. So weight of component A by its molar mass, what is that? It is nothing but number of moles of A. So molality equals to NB by weight by molecular weight. What is that? Number of moles means given weight by its molecular weight or molar mass. So what is that? It is number of moles. So weight by its molar mass. So I can write here number of moles of A into 1000 by molecular weight of A, like this. This is the final relation you can get, okay. So from this again you can take, instead of taking this number of moles, you can also write mole fraction of B by mole fraction of A into 1000 by molecular weight of A. That's it. This is the relation that you should use here, okay. Yeah, Tanveer in the chat box. Yes, so just listen the class. If you have any doubts, you can ask me here, okay. Yeah, So tell me what I can do here. So molality equals to, so what is the mole fraction they have mentioned? So what is this mole fraction of solute here? See, they have given acetone. Okay, so they have given the solution made up of acetone plus ethyl alcohol. So I am writing acetone plus ethyl alcohol. Okay, this is the solution they have used. So ethyl alcohol, see, mole fraction of acetone in ethyl alcohol is, mole fraction of acetone is how much? 0.3. Then mole fraction of ethyl alcohol will be how much? See, I told now sum of mole fractions will be equals to 1. Okay, so mole fraction of acetone is 0.3 means then mole fraction of ethyl alcohol is how much? How much? It will be 1 minus 0.3, that is nothing but 0.7. Okay, so we got these two things. Okay, but out of these two, which is solute and which is solvent? See, this is in major quantities now, so this will be our solvent. Okay, which is in minor quantities, that is our solute here. Okay, yeah. So now based on this, so solute is which one? Acetone, so that is 0.3 and solvent is 0.7 into 1000 by, so molar mass of A means a solvent. What is our solvent here? Ethyl alcohol. So ethyl alcohol formula C2H5OH. So its molecular weight will be 2 into 12 plus 6 into 1 plus 16. So this will be 24 plus 6, 30, 46. So here you take 46. So by simplifying this, what you are going to get? Your molality will be your answer. Okay? Yes. So molality you will be getting like this. So what is that? 0.3 by 0.7 1000 by 46. Just simplify, you are going to get your molality. So now what is the relation between molality and mole fraction? Once again, molality equals to NB means number of moles of solute by number of moles of solvent into 1000 by molar mass of A means here solvent. See, this is solvent, this is also solvent. So instead of saying number of moles, you can also say in terms of mole fraction as mole fraction of solute by mole fraction of solvent into molar mass of solvent. Okay, yeah, like this. Next, here, so we'll study about normality here. So just hold on. Let me check any other questions are there related to this. Just tell me answer for this simple question. Which of the following is dependent on temperature? Temperature dependent term in the given options. Temperature dependent. Very easy. How can we say? In the given molarity is temperature dependent. Only temperature, molarity or any other term? Molarity. So just I told you now, if in the given like terms, if it is having any volume term involved in it, that is temperature dependent. So only molarity is temperature dependent, other things are not. Okay, they are independent. Okay, next here. So I will be starting the discussion of normality here. So what is this normality? So it represents, see, just we have studied about molarity, right? So how can we define molarity? Tell me. How can we define molarity? Number of moles of solute present in 1 liter of solution. Okay, so 1 liter of solution. Similar to that, here it is also in 1 liter of solution. There we are saying number of moles of solute. Here you should say number of equivalents of solute. So there is a small difference between number of equivalents and number of moles. I will be showing you now. Okay, so now, so what do we mean by equivalence? See, for any substance, the weight of the substance, for there is a substance A, so the weight of substance that reacts with 1 gram of hydrogen. So the amount of this A that react with 1 gram of this hydrogen is called its equivalent or equivalent weight. Okay, so for example, like how can we relate this equivalents and number of moles? See, like number of moles means what is the formula? Given weight by its molar mass. Now I am saying number of equivalents. So number of equivalents means given weight, this is number of moles. Similar to that, what I am saying? Number of equivalents. That means given weight by equivalent weight. So what is this new term equivalent weight? So this equivalent weight should be taken like this. Equivalent weight equals to its molar mass divided by valency factor. Now you got one more new term. What is this valency factor? It means, valency factor means, let us say I have some acid here. So acid, let us say H2SO4 I have. So how many H plus ions this substance can release? 2, right? So 2 H plus ions and sulfate ion it is forming right now. So its N factor will be now 2. For example, HCl I have. How many it will release as? 1. So its N factor will be how much? N factor for this will be 1. So the number of H plus ion, in simple time if I want to say, what is the total positive charge released from it, or what is the total negative charge released from it, is its N factor for any term. Whether it is acid, salt, anything, I am generalizing it as a total negative charge, or you take total any one charge you take, that will be its N factor. Okay, is that clear or not? See, total positive charge is how much? 2 into 1, 2 only. What is the total negative charge? 1 into minus 2, that is minus 2. It means take only magnitude, just remove that sign. Okay, is that clear? Okay, so based on that, so we can get N factor. For example, what is the molecular weight of sulfuric acid? Tell me. 98. If you do that, you will get 98. So 98 divided by what is its valency factor? 2. So now its equivalent weight becomes how much? See, this will be 4, 9, 49. So what is a weight? If they give some weight, divide weight by equivalent weight, so that you will get number of equivalents in that substance. Okay, so if I give you weight as 98 grams, okay, what is its equivalent weight? 49. Okay, this is how much you got? Number of equivalents is how much? 2. So it means what you should understand is, if I say in 1 mole of, for 1 mole of sulfuric acids, in 1 mole of sulfuric acid, how many equivalents are present? How many equivalents? 2 equivalents. How you are saying? For 1 mole sulfuric acid, what is its molar mass? 98. So in this, how much you got here now? 2. So let us generalize this in a simple manner. See, simple manner I am saying here. So number of equivalence formula is what? Number of equivalence formula is, number of equivalence means you are taking weight by equivalent weight. Again, equivalent weight means what I told you? Molar mass divided by so can I write it here like this, valency factor or N factor, both are same only. So weight by molar mass, what is that? Given weight by molar mass, number of moles multiplied with its N factor gives us number of equivalents. So now what we got? Number of equivalents equals to number of moles multiplied with its N factor. So if I say 1 mole of sulfuric acid, how many equivalents it has? 2. So here also we got 2, here also you got 2. Okay, is that clear or not? Yes. Okay, yeah. Anshita. So dear Anshita, is that clear whatever I am discussing here? Yeah. So now, so in 1 mole of sulfuric acid, how many equivalents will get? 2, because its N factor is 2 for sulfuric acid, like that. If I say 3 mole H2SO4, so how many equivalents it has? Number of equivalents.
98 into 3.
Why you take 98? See, number of moles multiplied with the N factor. What is that answer? So number of moles is 3 into sulfuric acid N factor is 2. So this will be your equivalence of sulfuric acid here you have. Okay, right. Okay, so now what I am going to discuss is normality. Here I am discussing now. So now normality should be taken as number of equivalence of solute by volume of solution in a liter. Okay, if I want to express in ml, multiply with 1000. Okay, so number of equivalents in the short form I am writing number of equivalents as gram equivalent numbers, or gram equivalent numbers are number of equivalents, gram equivalents. Okay, so GEN number of gram equivalents by volume of solution. Let us say it is in ml now, then you can multiply here with 1000. Now I want to relate this equation with molarity and normality. How can I relate? Number of gram equivalents, what I can write here? Number of gram equivalents means n into n factor by v. Okay, here we have 1000. Okay, so similarly, like what is the next step? N by v into 1000 into n factor. So what is this thing? N by v into 1000. This if I express in ml. So what is this? This is nothing but molarity. So normality equals to molarity into n factor. Very, very important. When we are doing law of equivalence in redox reactions, we will be using this like anything. Okay, two things we are be using there. Like complete normality concept is very, very important. Normality means you should get two things in your mind. One is GEN by V. This should be in liters. Okay, now if I ask number of gram equivalents will be equals to n into V, that should be in liters. This thing you should get. Next, normality equals to, okay, again GN means what? In terms of molar, number of moles, what is the relation we got? Number of moles and GN, number of gram equivalents, n into n factor. Right now, just now we discussed. This relation also very, very important. I will be asking you when we are discussing in the redox reaction, law of equivalence. Okay, this is another thing. And one more is normality equals to molarity into n factor. These these formulas are very, very important. We will be discussing about this and we will be using this like anything when we discuss redox reactions. Okay, try to write them and we will move forward. Over? Yeah. Let us discuss few more things. Yeah, scroll up. Done? Yeah. So now see, for calcium here if you see, so calcium is an element now. So what is its n factor if I ask? See, for an element how many electrons it is losing? Ca plus 2 it will become now. So what is the total positive charge here you are seeing here? 2. So its n factor will be 2 like that. Okay. So now if I ask number of equivalents, what you should say? N into given number of moles multiplied with its n factor. If I say 2 moles of calcium I say, so 2 into 2, so 4 equivalents of calcium you should say, okay, in that given substance. Now if they ask for equivalent weight of calcium, how can you do that? Equivalent weight means what? Molar, like given weight by its
N factor.
like, see, sorry, what I am asking, equivalent weight equals to molar mass by
N factor.
its n factor. What is its equivalent weight? Like what is its molar mass for calcium? It will be 40 and n factor is 2, so that you are going to get so 20 here. Molecular weight is 40. Okay. So similarly for sulfuric acid we discussed. Okay. So for bases, in case of base, see calcium hydroxide we have. So how many OH minus it is releasing? Ca plus 2 OH minus ions. See, I just told you that one generalized statements, total negative charge or total positive charge, whether it is maybe any of the compound. See, if it is base, total negative charge is how much? 2 into minus 1. So minus 2. Total positive charge is how much? Plus 2. So either you take positive charge or negative charge, that will be its n factor. Next. Okay. So now what we are going to discuss is when two solutions of different concentrations are mixed. I have a solution with concentration M1 and with volume V1 and another solution with concentration M2, volume V2. Both solutions are of same type. For example, I have both HCl solutions. Like these are what? HCl, acid solutions. Maybe HCl or any other thing. Let us consider HCl. Okay. What I am saying, both are of similar nature. Either acids both or bases both. Okay, of similar nature I am saying. Remember that point. So when we mix these two things, when I am mixing these two things, what is the resultant concentration? What is the resultant concentration? Like this they will ask. Okay, so you just use this formula. So M resultant, molarity of resultant solution is equals to, add these two things, M1 V1 plus M2 V2 by V total. So V total is nothing but V1 plus V2. Okay, not only that, if I add some amount of water to that, so V total becomes what? V1 plus V2 plus V water, like whatever the amount of water you added, take that. So take it here in the denominator, so that you are going to get your answer. Okay, is that clear or not? Yeah. Now we will see one question on this. See, yes.
If H2O is there,
Huh?
then how we can take N factor? Either two hydrogen or one oxygen?
Huh. Actually here when we are discussing about N factor, so that generally we will discuss it for strong acids and strong bases. Okay, see water is a weak electrolyte.
Yes.
Okay now. So even we discuss for like solute particles first of all. Mostly whenever we are considering water, it will be what? A solvent.
Yes.
Okay, we are discussing the concentration with respect to what?
Solute.
Is that clear or not here? Okay, next. So tell me for this, what is the answer? Tell me for answer for this. If 0.1 molar HCl and of 50 ml mixed with 50 ml of 0.2 molar HCl, what is the resultant concentration of acidic solution? Tell me. So tell me your answer for this question. Anyone? So M resultant equals to what I should say? So anyone in the chat box can answer this? 0.1, M1 is 0.1, its volume is 50 plus M2 is 0.2 and this is also 50, V2 also 50. So this V1 plus V2 100. So what is this value here? 1, okay, 5, and here it will be 2, it means 10 by 100. So 15 by 100 or 15 into 10 power minus 2, or you can simply say 0.1215 molar solution. Okay, 0.15 molar solution. Is that clear or not? Yes. Okay, next we'll move forward with few more questions. Take this as a homework question. Write this question and tell me answer in the next class. Okay, next thing here is over. Next thing here is what we have discussed here in previously M1 V1 na? So always remember for this kind of calculation, when we are mixing two solutions, always use N1 V1 plus N2 V2 by V1 plus V2 or V total when you are trying to find resultant concentration. Even if I have given molarity, but always what I am suggesting you to use normality, not molarity. Why? Because in the previous case which I have shown here, see what is the N factor for this? Sulfuric acid, 2. Okay, so here also it is sulfuric acid, here also it is 2. So there is no issue in this case. But you know, when I give one HCl and one sulfuric acid, now what about its N factor? 1. Its N factor 2. So concentration varies now because of its N factor. See, molarity normality, what is the relation? Normality equals to molarity into its N factor. So here also M into its N factor. See, if I say 1 molar solution, 1 into its N factor also 1. That is N is also 1, there is no issue here. But here molarity, if I say this is 1 as of same like this, molarity is same only, but normality becoming differ because of its N factor. So it becomes 2 normal, this is become 1 normal. So due to this difference, what I am suggesting, always use normality when you have different N factor solutions. Okay, if they are of same type, no issues here. Okay, so you just use the formula and try to get the answer for this question like N1 V1 or M1 V1 for this.
We have to know use of N factor. So we have to know use of N factor. Only we have to substitute M1 V1, M2 V2.
Here in this case no issues, but if I give one HCl and one H2SO4 and I am asking you to find its resultant normality or resultant pH, they will ask. What you going to do? So in the pH case, I will tell you what to do in the upcoming class. Just use the formula pH equals to, as of now if you find any questions, just use this formula. Minus log concentration of H plus ion in terms of normality. Okay, it should be in what? Not in molarities here. Okay, yeah. Even if it is molarity, convert into normality by multiplying with the N factor. Okay, next. Look at here, 20 ml of, see 20 ml of 0.1 HCl solution is added to 30 ml of 0.1 NaOH. To this extra 50 ml of water is added. Okay, then what is the resultant molarity of the solution formed? So how can you do this again, tell me? Are they of same nature?
No.
HCl and NaOH. These are of different now. So acid base we have. So in this case acid base what happens? Neutralization takes place now. So it means concentration decreases here because acid base reacts, therefore their concentration decreases. So you can say this is neutralization process. Okay. So now in this case the one which is having more number of equivalents or more number of moles here, you should take that. Okay, see here what you need to use is N resultant should be equals to N into V of acid minus N into V of base mod I am putting here. Why I am putting mod this will tell you. So total volume is how much? V total. V total includes Va, acid volume, base volume. If any water is also added, consider here. So now tell me here what I can take.
0.1.
What is its concentration? 0.1 into 20 minus 0.1 into 30 by V1 is how much? 20. V2 is how much?
30.
Then next
50.
50. Again this 50 also should be added. So it becomes 100 here. V total will be 100. Okay. So therefore what you are going to get here? See why I told you to add mod here means just look at here. This will be 2 and this will be 3. So 2 minus 3 will be minus 1. So your answer should not be in negative terms. Okay. To avoid that what I told you just put mod. Okay. So now here you got 100. So that you are going to get 1 by 100. That is nothing but 10 power minus 2 or 0.01. So 0.01 here you have option C. Option B your answer. Next what is my question is whether tell me whether this solution is acidic or basic. See look at here which value is more, this first term value is more or second term value is more. So second term value is more now. So resultant solution will be second term, that is B, base. So solution is basic. What is that? Solution is basic. Okay. And what is its concentration? 10 power minus 2. Okay. Now if they ask for pH, okay, so how do you going to do this? So actually pH means minus log concentration of H plus. This is basic now. So this is the concentration of OH minus ions. This is concentration of what? OH minus. So you should find here POH, not pH first. So pH means minus log concentration of, see when I say pH you told minus log concentration of H plus. If I say POH you should say minus log concentration of OH minus. That should be in normalities. Okay. Yeah. Now tell me how much it is? Minus log concentration of OH is how much? 10 power minus 2. Okay. POH is how much? Minus 2 into 2, that comes here. So POH is 2. Okay. Yeah, like this you should do. So we got POH now. So what is the relation between pH and POH? This is equals to 14 at 25 degree Celsius. Okay. How this is 14? Because what is the neutral point here in the pH scale? At 25 degree Celsius. So from 0 to 7 acidic, 7 to 14 basic. So total values are 14 now, 0 to 14. So I am taking it as total sum is 14. I want pH. What is our POH? So pH will be, so that will be 14 minus 2 means 12. This will be your answer for POH and pH and POH. Like this you need to solve. So just make a note of it.
Sir, if
Yes.
2 also acid, then we have to add
Yes.
because of acid and base we are subtracting.
Since this is acid and base, neutralization takes place, no? So we are subtracting. over next. So can you solve this question based on the previous class discussion? See, you are doing many PYQ questions here in the class itself. Just practice the other questions from the book. See, molarity of 50 ml of sulfuric acid is this much, 10 molar. If the density of solution is given this much, then calculates its molality. This is what? Calculates its molality. So what is the relation between molality and molarity? Small m equals to, I told you in the last class, capital M 1000 by density into 1000 minus molarity into molar mass of B, solute. Okay, use this formula to get the answer. Just try it, and yeah, you can use this formula based approach. So along with this, just normally also you can do by conceptual, or you can use this formula also. So what is the value here they mentioned? Molality equals to, molarity is 10 into 1000, and what is the density mentioned? 1.4 into 1000 means it will become 1400, right now. The next molality is 10 into, what is the molecular weight of solute? Sulfuric acid is 98. 98 into 10, 980. Okay, therefore you get, see 980 now, so 10 and 10 in the denominator, 10 in the numerator I can remove. So 1000 by 140 minus 98. 140 minus 98 is how much? 42. 42 now. Okay, so next if I remove the 0, it will become 4.2, 100 by 4.2. So 4 5s are 25. Sorry, 25 4s are 100. 25 4s are 100. So here if I go 4.2 means it should be lesser than 25. So you are going to get this value approximately how much? 24. What is your answer for this? 24. Do you got what is my approximation here? See, 42 I have, 1000 by 42, I can write 100 by 4.2. So 4.2 into 24 if you do, you will get a value around this. Okay, so that's why I am taking it as 24. This is the nearest number. Okay, is that clear or not? Yeah. Will you try this? Molarity of 1 molar glucose solution having density. Okay, take this as homework, write it. Yeah, now written this question. Okay, so next question, see this is about all about concentration terms. Okay, just take these questions as homework, just give a try for all these questions. Okay, and yeah, these questions I just wanted to show you. Just tell me for this, what's your answer? This is effect of temperature based question. If 2 grams of NaOH is dissolved to make 200 ml of solution at 25 degrees Celsius. So what is its molarity at 90 degrees Celsius, whether it is increases or decreases? See, 2 grams of NaOH. Molarity at 25 degrees Celsius is how much? Tell me first of all. Number of moles of solute is how much? If this is 2 grams, so given weight is 2 grams. What is molar mass of NaOH? 40. And what is the volume it is mentioned? 200 ml. If it is ml, 1000 by 200. So it will be 5 here. Okay, then next this will be 20. Okay, this will be 4. So you got 1 by 4, or I can say 0.25 molar solution at 25 degrees Celsius. Now they are asking this at 90 degrees. How can you do this at 90 degrees? What is the effect of temperature? At 25 degrees Celsius you got 0.25. So molarity at 90 degrees. What happens to this? Just look at the formula. M equals to N by V right now. So if temperature increases, what happens to the volume? Expansion takes place, volume. So volume also increases. If temperature increases, V increases. If this is increasing, this is inversely proportional to molarity. If this increases, this will be decreases. So now what happens to the molarity? Decreases. So where do we have option C? This is equal they are saying. It means this is incorrect. They are saying it will be greater than 0.25. Is it greater than 0.25 or less than 0? Less than. So where do we have it is less than? Only option A will be our answer. So simple only now. Just based on our understanding what is the effect of temperature. So do you got what is how it will affect? So molarity is a temperature dependent. Okay. So dependent, that's why this change is appeared here in the question. Okay. Right. It is clear now? Yes. Okay. Next thing is, do you remember, do we discussed about empirical formula and molecular formula? Okay, just look into the questions once, like topics once we discussed. Okay, now I will be giving you one question from our module. Just try that. See, a compound X, X is made up of or contains, this is a PYQ question, so make it as it is, contains 32% of A and 20% of B and remaining is C. Then the empirical formula, of compound is, what is the empirical formula they will ask. Okay, given data also they mention here, given molar mass of A is 64, B 40, C 32. So tell me answer for this. See, what is empirical formula? Tell me first. Empirical and molecular formula means, see, chemical formula is of two types. Chemical formula, it means what? The symbolic representation of a given substance. For example, I am saying acetic acid. What is the symbolic representation? Like your symbolic representation is something like this right now. Okay, this is what the chemical formula of the acetic acid. Okay, so this chemical formula is of two types. How many types? Two types. One is molecular formula and another one is empirical formula. Okay, so molecular formula means, so it represents exact number of each atom of an element in the molecular that compound, in the molecular that compound you can say. And what about empirical formula means here? It is the simplest whole number ratio, simplest representation, or you can just write simplest representation of this molecular formula. It means in the simple terms, I am saying here acetic acid is a chemical formula of this compound. So what is the simplest way of representing it? Okay, so here how many carbons are there? 2, C2H4O2. So what is the simplest way I can represent simplest whole number ratio here? CH2O. So CH2O is the empirical formula of acetic acid, and this is the molecular formula of this acetic acid. Now how can you relate empirical formula and molecular formula? Molecular formula equals to empirical formula multiplied with some whole number. So what is the whole number here I should take? 2. The whole number in this case is 2 here. Why? Because see, this is the empirical formula. If I multiply this with 2, you will get C2H4O2. Okay, so that will be the whole number here. So now tell me, what is the empirical formula of this benzene? Okay, and benzene here, and acetylene. I am saying, see, just I will be giving like this, benzene and ethine. Okay, and the next glucose. Write molecular formula and empirical formula, glucose, and the next acetic acid and formaldehyde. These 3 things, and along with this formaldehyde you just write their molecular formulas and empirical formula, what is the whole number ratio for that. Okay, so now tell me, how can you solve this question, previous question? See, what is the weight of A given? 32%. It means 32 grams in 100 grams of that compound. So weight of A is 32. What is its molar mass? 64. This will be 1 by 2, and B will be 20 by 40. This is also 1 by 2, and C is 32 plus 60 is 32 plus 20 is 52. So 52 for A and B. Then C will be 100 minus 2. That will be how much? 48. So take here 48 by 32. This will be 3 by 2. So A 1 by 2, B 1 by 2, C 3 by 2. So what is the simplest whole number we can get here? A1, B1, C3. C3. We have an option now? Yeah, that will be your answer. Okay. So now we are almost done with this first chapter. Now you just give a try for the numericals, PYQs from this first chapter. If you have any doubts, you can ask me. Okay. We will start the new chapter in the upcoming sessions. Okay. So that's it.